Let's look at the solutions of Algebra Quant Crusades. If all the three roots of the cubic equation x square plus kx plus or minus 286 equal to 0 are integers, then which of the following is true? Now see, this is a cubic expression, and within this we don't really have the term x square, which means its coefficient should be 0, and coefficient of the second highest power is sum of the roots. We know product of the roots is either 286 or it is minus 286, and the sum is 0. If the sum is 0 and the sum turns and the product turned out to be 286, it could potentially be when two roots are negative and one is positive. 286 by itself, when you factorize it, this is equal to 2 into 11 into 13. I need to break it up in such a way the two numbers are negative and the sum turns out to be 0. Of course, the case we are working with is minus 2, minus 11 and 13. In this case, what are we working with? I need the product to be negative and sum to be 0. So one term has to be negative and sum is 0. So of course, the case we are working with is 2, 11 and minus 13. Now k here is sum of pairs of roots taken 2 at a time. So we'd have 22 minus 26 minus 143. This would be the value of k in the first case. In the second case, the value of k would be 22 minus 26 minus 143. I don't even wish to engage in maths. Can you see the value of k in both these cases is turning out to be the same number and it is a negative number. So of the four options, value of k is a unique negative integer. Next, a function fx is defined such that it satisfied fx is equal to x square minus f of x minus 1 for all real values of x. If f10 is equal to 21, then find the value of f27. Okay. Can I say f27 plus f26 would be equal to 27 square? If I bring it to the left hand side, no, this is not ideal. This is not ideal. I'll show you what is ideal. f27 is equal to 27 square minus f of 26. If I try to write down f of 26, it is 27 square. Sorry, not 26 square minus f of 25. If I try to write down f of 25, this is equal to 25 square minus f of 24. If I replace it backwards, can I say f of 27 is equal to 27 square minus 26 square plus 25 square minus f of 24? I've simply put f25 here. So minus 25 square plus f24. When I put it even further back, this minus 25 square will turn to plus 25 square, so on and so forth. In fact, now I have come up with an expression in which I can extend it to whatever length I want to. Can I go f27 is equal to 27 square minus 26 square plus 25 square minus 24 square plus 23 square minus 22 square all the way up to f10. Finally, we were getting a term in f, no? So I'll put it down as f10. But let me see if f10 was positive or negative. It is, see, the odd number squares are positive and the even numbered terms are negative. So this will be minus, and prior to this, I will have 11 square. Okay. In fact, prior to 11, I will have minus 12 square plus 13 square. This is what is happening. Now, if I have to simply find out this sum, these two add up to 53. These two add up to 49. These two add up to 45. Hopefully, you can see you have an AP of common difference 4 happening. And these two add up to 25. From 25 to 53, AP of common difference 4 is created. And for the last two terms, 11 square is 121 minus f of 10, which is 21. So this is 100. So now we have 53, 49, 45, 25. Let's add them up. 53 plus 25 is 78 by 2 into how many terms? 8 terms, I'm guessing. Let's deduct 21 from it. Let's deduct 21 from it. Yes, 32. So 8 terms plus 100. This is what I'm supposed to do. So cancel, cancel. Gets me 4. 8 into 4, unit digit 2 plus 100. The only option with unit digit 2 is option C. That should be the answer. Okay. Next one. Find the area in square units of the region bounded by mod x plus y. Mod x plus mod y is less than equal to 6. Okay, let me try to draw a diagram which is not as bad. I'm not very good at drawing beautiful looking diagrams. Functionally, they would work, but beautifully, not so much. Okay. Mod x plus mod y is less than equal to 6 would mean these are the points. You'd get a rhombus. The points here is 0, 6, 6, 0, 0, minus 6, and minus 6, 0. These are the 4 corners done. And x plus y mod is greater than 2. And now this is interesting. If you only want the points on axis, it would be like this. This would be 2, 0, and 0, 2. In fact, I should use a different color. 0, 2, 2, 0. And the line will go something like this. Similarly here, we will have 0, minus 2. And here it will be minus 2, 0. Another line will go this way. What they are asking me for area, what the question asks for area is this region. The region bounded by these two sets of lines. Now, for the entire huge rhombus, hopefully you can see the area is very easy to calculate. Half into 12 into 12. The diagonal lengths are 12 and 12. So we get 72 from there. And from that, all I have to do is remove this area. Let's see what this area would be like. First thing we need to identify are these intersection points. The gap between these 2 points is 4. The slope here is 1. The slope here is 1. Each of the expression has slope of 1 only, so not a problem. Slope here is 1. Slope here is 1. So a gap of 4 would be covered when you move 2 rightwards. So the coordinates of the point here would be 2, minus 4. The coordinates of the points here would be 4, minus 2. The coordinates of the points here would be minus 4, 2. And the coordinates of the points here would be 4, minus 2, 4. Basically, if you want to get this length here is as good as the length of the original rhombus. This is 6 root 2. This is 6. This is 6. So this is 6 root 2. Now for this length here, because a rectangle of sorts is getting created, can you see a right angle? From the point 2, minus 2, 2. This is height 2. This is base 2. So this should be 2 root 2. This should be 2 root 2. So I've got for my rectangle, the middle rectangle that is getting created, the sides are 6 root 2 into 2 root 2. This will give me the area of this middle black portion. This is equal to 24. So 72 minus 24. Answer will be 48. Okay. Next question. Consider the two function x square minus 8x plus 11 and gx is equal to x square plus 12x plus 13 attain minimum value at P and Q. So if it is attaining at P and Q, it is attained at minus B by 2A. So for the first expression, it would be at 4. For the second expression, it would be at minus 6. Finally, we need, this is P, this is Q. We need P minus Q. So it will turn into 4 plus 6. Final value, 10. Next question, a function is defined on real numbers as followed. Fx plus 2f of 2 minus x is equal to x square. Find the value of f6. Okay. This is a very standard question. You simply plug in the value f6 plus 2 times of f of minus 4 is equal to 36. And now, because we don't know value of f of minus 4, go ahead and plug in minus 4. F of minus 4 plus 2 times of f of 6 is equal to 16. So now we have 3 times of f of minus 4 plus 3 times of f of 6 is equal to 52. So f of minus 4 plus f of 6 is equal to 17.33. Now look at this equation and compare it to this equation. By adding an extra f6, you're effectively adding minus 1.33. 17.33, the value has gone down to 16. So value of f6 is minus 1.33, or option B. How many integral values will satisfy the given inequality? Blah, blah. Okay. This is a very modulus heavy understanding question. Please pay attention. First thing we'll do is we'll multiply these things. We'll get 6 minus mod of 9x, 6 plus mod of 9x minus mod of 9x divided by 2 plus mod of 3x. This has to be greater than or equal to half. Now this is gone, this is gone. And this whole thing was also under mod. This whole thing was also under mod. This is gone, this is gone. I'm left with 6 by 2 plus 3x. Now see, beautiful thing. This external mod is actually useless. Why this external mod is useless? The numerator is positive, 2 is positive, 3x is positive. Everything is positive only. So positive by positive is going to be positive only. So I don't really need these external mods. I can happily turn to 12 is greater than or equal to 2 plus 3x mod, or x mod is less than 10 by 3 or 3.33. Because we are looking for integral values, the possible values that x can take are minus 3, minus 2, minus 1, 0, 1, 2, and 3. These 7 values. Answer has to be option C. Again, a standard question. A raised to the power 8 plus 1 by a raised to the power 4 is given to us is equal to 527. Very format-based question. So we go ahead, a raised to the power 4 plus 1 by a raised to the power 4 plus 2, just to complete the square, is equal to 529, which gives us a square plus 1 by a square is equal to 23. I'm directly jumping to this because we are told that a is a positive real number. So we are only considering the positive root. So a square plus 1 by a square is 23. Again, just like the previous case, add a 2, we get a plus 1 by a is equal to 5. Now we need this expression, which is as good as a cube plus 1 by a cube. Cube it up, we'll get a cube plus 1 by a cube plus 3 times of a plus 1 by a is equal to 125. This will turn out to be a total of 15. This goes to the other side, minus 15. Our final answer will be 110. Option A. Moving on. Find the value of the following expression. 1 plus 1 plus 5 plus 1 plus 5 plus 5 plus 5 square, 1 plus 5 plus 5 square plus 5 cube, blah, 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 up until 5 raised to the power 49. Hopefully you can see this one is nothing but 5 raised to the power 0. First thing is, this one is nothing but 5 raised to the power 0. So can you see 5 raised to the power 0 has been given to us 50 times. 50 times I have 5 raised to the power 0. Then I have 49 times 5 raised to the power 1. Then I have 48 times 5 raised to the power 2, so on and so forth, up until I have just one time 5 raised to the power 49. Let's say this summation was equal to S, and this is a standard setup for arithmetico-geometric progression. I have to multiply it by 5 now. 5S will be equal to 50 into 5 raised to the power 1 plus 49 into 5 raised to the power 2, blah, 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 blah. 2 into 5 raised to the power 2 into 5 raised to the power what? 49. And finally, plus 1 into 5 raised to the power 50. This is what we are getting. Okay, so 5s minus s, overall, I'll get 4s is equal to, this portion will remain as it is, 5 raised to the power 50. This will give me 5 raised to the power 49. Then 5 raised to the power 48. Everywhere I will simply have powers of 5 left. And this will keep on happening up until 5 raised to the power 1, except this term will be present in the negative form right at the end by 50. Now this is a GP, a simple GP. I can find out the summation here. This is a simple GP. If I don't look at it left to right, I look at it right to left. If I look at it from right to left, it would be simpler, because then I can say 5 is A. How many terms are there? A raised to the R raised to the power N. R raised to the power N, number of terms is 50. 5 raised to the power 50 minus 1, whole thing divided by R minus 1. So 5 minus 1. 4s is equal to this minus 50. This much we have got. Okay. So from here, this 4 will come down. Niche, s is definitely equal to 4 into, oh no, I should not make it jump straight away. 5 raised to the power 51 minus 5 minus 200 by 4. And now I have s is equal to 5 raised to the power 51 minus 205 by 16. Therefore, the answer to the question should be option D. Okay. In how many ways can pairs of integers xb be chosen that such that x square minus 4x plus b minus 3 is equal to 0? Now see, x here, this expression is given in x only, and x also happens to be a root of this expression. So given that we have a root of expression as integral, that is another way of saying that the discriminant d part has to be a positive number and a perfect square number. So d here is given by 16 minus 4 times b minus 3. This has to be greater than 0. This has to be greater than 0, and it has to be a positive number. Now hopefully you can see it has to be greater than 0, and it has to be and a perfect square. Now see, 16 minus 4 something, the result that you get on your right hand side will be even, and it has to be a perfect square less than equal to 16. So can you see the possibilities are very limited? Either you will have this expression equal to 0, or you will have it equal to 4, or you will have it equal to 16. So let us list out all those cases. First is 16 minus 4 times of b minus 3 mod. This is mod here, sorry. Is equal to 0, which gives me b minus 3 is equal to 4. So b is equal to 7 or minus 1. But it doesn't stop here. Just because you've potentially identified a value of b, that doesn't mean a value of x has been identified. In order to identify value of x, you have to go ahead and replace in the original equation b minus 3 is equal to 4. So the equation will turn to x square minus mod of x, 4 mod x plus 4 is equal to 0. And this can be reduced to this. So x can be equal to 2 or minus 2. You have two possibilities for B. You have two possibilities for X. We are looking for pairs of XB. Can I happily say 4 pairs I've gotten from here? I can have 2, 7, 2, minus 1, minus 2, 7, minus 2, minus 1. So 4 pairs I've got. And this is only when we were taking it as 0. Next case would be 16 minus 4 times of B minus 3 is equal to 4. So next work would be 4 gone here. Okay. B minus 3 mod is equal to 3. So B is equal to 6 or 0. This much we have got. If B is equal to 6 or 0, work is not done. We have to go back and replace it in the equation. B minus 3 mod was equal to 3. So I've got x square minus 4x plus 3 is equal to 0, which can be happily broken down into mod x minus 1 into mod x minus 3 is equal to 0. So x can now be 1 or minus 1 and 3 or minus 3. Now see, x can take 4 values, b can take 2 values. We can come up with 8 pairs now. We can come up with 8 pairs now. 4 pairs are identified, 8 pairs are identified, and we are left with just checking the last case when 16 minus 4 times of b minus 3 mod is 16, which would roughly be equal to 4 times of b minus 3 mod is equal to 0 or b is equal to 3. This is guaranteed. If b is equal to 3, the original equation will now turn to how much? X square minus 4 mod x is equal to 0. So if I take x mod outside, I'm left with x mod minus 4 is equal to 0. So x can potentially take values of 0 or 4 or minus 4. These are the 3 values x can take. 3 values that x can take. B can take just 1 value. So we'll get 3 more pairs from here. Altogether 4 plus 8 plus 3. There are 15 pairs. Therefore, option D. Okay, next question. If T1 is plus T2 plus T3 plus T4, so on and so forth, up until Tn is equal to this. For n being a natural number starting from 1, find T25 minus T15. Okay, I'm trying to do something. If the summation of this expression is a cubic, if the summation of these terms is a cubic, can you see the original general term? The original general term has to be a quadratic. An square plus bn plus c. So when I take n equal to 0, sum up till 0 terms will be how much? According to this expression, sum up till 0 terms is 0. So c is not even involved. There is no constant term in this expression. Now I'm saying if I take sum up till term 1, would be 1 into 2 into 3, whole thing by 3, which is equal to 2 itself. So term 1 is also 2 itself, because sum up till term 1 or term 1, they're the same thing. Now let's look at sum up till term 2, T1 plus T2. T1 plus T2 is equal to 2 into 3 into 4 by 3, cancel, I get 8. Now see, T1 plus T2 is 8 and T1 is 2. So can I say T2 is equal to 6? T2 is equal to 6. As soon as we have arrived at this, now we know the general term. We know the first two terms. Let's go ahead. A plus B is equal to 2 and 4A plus 2B is equal to 6, which can be simplified as 2A plus B is equal to 2A plus B is equal to 3. From here to here, and A is coming in, value of 1 is rising. So A is 1, B is 1. The general term for this expansion, this expression is n square plus n. This is it. So when they're asking me to find T25 minus T15, what I have to actually find is 25 square plus 25 minus 15 square minus 15. Okay, so 25 square minus 15 square is 400. 25 minus 15 is 10. So altogether, I should be reaching option C. This time the explanations, I have tried to keep them more detailed than what I usually do, because I was told that explanations don't always make sense. But okay, I see explanations don't always make sense on account of two reasons. One, I'm insanely I am a mad scientist. Okay, if you want to believe that. The other, maybe your area is not covered. That is also possible. I'll treat that as a possibility. The third, more genuine reason could be that every maths teacher, every quant person has a different way of referring to separate things. Every quant person has a different way of referring to separate things. Maybe you know these ideas, but you know them in a different way. I know them in a separate way. You know them in a separate way, because your reference points would be heavily influenced by what teacher you studied it from. So this is more to do with people who are studying in my class can make sense out of my videos more. People who are not studying in my class, they'll make some sense out of it, but there will be times, for instance, this graph drawing, I'm not sure how many people will understand what I have done within this graph, and I can't explain it more because this is how much time isn't. This is still, let's say this was the entire video length of solving part was roughly 1.75 times of what the actual time to solve should be. A lot of these questions don't really require explanation. Say something like question 4 is a straight solving question. Even question 5 to an extent. Question 6 requires some level of solving. Question 7 is a straight solving question if you know these terms and everything. Question 8 is an AGP, very familiar, very usual question. Question 9 is excellent. Question 9 takes a lot of time and deserves a lot of time. Question 10 is also very, very standard. In fact, this expression, if you haven't seen it at least 50 to 60 times already, uh, probably you're not practicing from the right sources. This is very, very popular. This is very, very popular. As in, all the investigative time that I spent in identifying this general quadratic term, I knew it from the moment this expression was seen. Hopefully you learned something. That will be all for Quant Crusades this time. Okay, people, bye.